morning. Today is 22nd March and we are now going to begin the last exercise of sequence and series. Last exercise, that is exercise 1G. This exercise is exercise meant for the special series. So what are the type of series we will meet with in this exercise? I have tried to show you with this, and then all these are three important results. So these three results also you have to list down in your formula notebook. Okay. So first of all, we have sum of the first and natural number. Sum of the first and natural number. You know the sum of natural number, right? Sum of the natural number is 1 plus 2 plus 3 plus 4 and so on, right? This is how we write the sum of natural number. Now this sum of natural number we can denote as summation of n. Summation of n. Is it okay? And this is the formula which is made to calculate the sum of n natural numbers. The sum of all the natural number can be denoted by this notation. This is the notation which can represent the sum of n natural number, and then this is the formula which can be used to calculate the sum of natural number, right? You want to find the sum of 10 natural number, you can use this formula. Sum of 20 natural number, sum of 50 natural number, sum of any number of natural number you want to calculate, you will use this formula. So in this exercise, whenever we are asked to calculate sum of natural number of certain numbers, then we will use this formula. And this is the notation to represent the sum of natural numbers. Is it very clear? So the sum of the natural number we can calculate by using the formula n into n plus 1 divided by 2. Second formula is sum of the squares of the first n natural numbers. Sum of the squares of the first n natural numbers. Sum of the squares. Like suppose square of 1 plus square of 2 plus square of 3 plus square of 4 and so on, right? So we call this as sum of the squares of the natural number, because the numbers we have is 1, 2, 3, 4 again, but this time we have all these numbers in the form of a square. All these natural numbers we have in square form. So we are trying to find out the sum of the squares of the natural number. So the general notation for this can be sigma n square. Sigma means sum of what? N square. And where is n is natural number. That means we are trying to find out the sum of the square of the natural number is denoted by this notation, and we can calculate the sum of the natural number by using this given formula, n into n plus 1 into 2n plus 1 divided by 6. Is it alright? Likewise, we have a formula for the cube also. We have a formula for cube, sum of the cube of the first n natural number. Once again, here also I will show you what is the meaning of cube. Sum of the cube of the first n natural number means the natural numbers you know, like are 1, then 2, then 3 and so on, right? These are all natural numbers. And if you have to find out the sum of their cubes, then this is denoted by a common notation, summation of n cube. Summation of n cube. And then mathematically we can represent it like this. Is this very clear? So by using this formula, we will be able to calculate the sum of the cube of any number of natural numbers. If you want to find out the sum of a cube of 10 natural numbers, you can use this formula, and then the value of n will become 10. Hope this is very clear. So there are three formula, 1, 2 and 3. If you look at these three formula carefully, you will notice one thing is this sum of the cube of the first n natural number is nothing but just the square of the sum of the first n natural number. So if you can remember this, then you can also remember this formula, because this is simply the square of the first formula. Is it okay? So with this we will begin the exercise. Alright, now we are moving on to question number 1 of exercise 1G. The first question is find the sum to n terms of the series. Find the sum to n terms of the series whose nth term is given as so and so. So we can use the formula which we have seen just now, and we can try to find out the sum of this series. We will find out the sum of n terms of this given series 4, and this is n cube. N cube is the sum of cube of natural number, sum of the cube of first n natural number. So we can write the formula that we have seen just now is n into n plus 1 divided by 2, and then the formula was whole square. Clear? Now plus next term is 6n square. So 6 and n square is the sum of the square of the first n natural number. The formula for this one is n into n plus 1 into 2n plus 1 divided by 6. This is the formula for the second term. And third term is 2n. 2 and then n is the sum of n natural number. The formula for that sum of first n natural number is n into n plus 1 divided by 2. Is it okay? So we just have to simplify this part, and then that will give you the sum of n terms of the given series. Is it alright? So let us start this. Now, outside the bracket there is a square sign. Outside the bracket there is a square sign. So when I apply the square, then this n will become square, this n plus 1 will become square, whole square, and this 2 also will become square. So when this 2 becomes a square, it will become 4. And outside we have 4. So we will cancel this with 4, outside 4. Hope you have understood, because this is 4 and this also is 4, because we are applying this square on this one. So it becomes 4. After this, now in the next step, we are going to open this. Now similarly, this 6 and this 6 will be cancelled, and this 2 and this 2 also will be cancelled. Alright, now here this is n into n plus 1, n square, now we are applying square here, and then square. This is plus n into n plus 1 into 2n plus 1, and then plus n into n plus 1. Did you get it? Now, if you look at this, all the terms, no, all this term, this you will look at this term, and this term. Then you will find that n into n plus 1 is common in all the three. So we will take it out common factor. It is n into n plus 1. We will take out common factor. When we take out common factor, from here it will be just n, and then from here it will become n into n plus 1. Clear? From this part, this n into n plus 1 is already out. Now we are left with only 2n plus 1. 2n plus 1. Clear? Done. Now from this last term, n into n plus 1, everything is taken out. That means here we will be left with just 1. Hope I am clear? Okay. Now in the next step, we will see here this is n into n plus 1 as it is, and then, okay, you open the bracket. This bracket when you open, then you have to multiply. Is it okay? This bracket can be simply open, and then we can use this 1. So this we will keep as it is, n into n plus 1. For some time we will keep this as it is. We will not operate this part. If necessary, we will see later on. And then the other thing will become 2n plus 1 and then plus 1. Right. You can see here plus 1 and plus 1 are common. So we can add this to are the like term. So we can add it. In the next step, it will be n into n plus 1. And then this is as it is first term for the time being, n into n plus 1. Now 1 plus 1 is 2. So this will become 2n plus 2 plus 2n plus 2. Is it okay? Now one more step. Now when you see this 2n plus 2, do you find any common factor here? The common factor of these two is 2. So we will take out the common factor from here. This will be n into n plus 1, and then n into n plus 1 as it is, and from here you take out the 2 common factor. This will become then n plus 1. Am I right? Now when you see this, why I was not multiplying, this is because of this reason only. because now from this and this you can see n plus 1 is common. So we will take it out and we will get the final answer. So this outside bracket is n into n plus 1, and then here again n plus 1 is out, n plus 1 is once again out. Now inside the bracket from here you get n, and from here you get plus 2. Is it okay? So final answer, because here these two are same, so we can multiply. Therefore it will become n into n plus 1 into n plus 1 will become n plus 1 whole square, and then this is n plus 2. N plus 2. This becomes your answer. Is it very clear? Thank you. Alright, now we are moving on to question number 2. The question number 2 says find the sum of the series. Find the sum of the series. Now you can see this is given in the form of product. This is a very special series. We have to find the sum of this series. Now if you look at this series, then you will find that this single series, which appears to be a single series, is actually a combination of double series. Right? I will show you. We will segregate the two series, okay? The first series is with the first term of all, okay? So this is one series. This is one series. Can you see this? This is one series, right? So if I see only the underlined, then this is one series. So first of all, since we have to find the sum of the series, right? And we know that this series is a combination of two series. This single series is actually a combination of double series, right? So we will have to see the two series separately, and we will find out the nth term for the two series separately, right? And then we will combine and then get the nth term of the single series. Are you getting my point? I repeat, this single series is a combination of double series, right? So we will first segregate the two series, and we will try to calculate the nth term for each series, right? And after the nth term of each series is calculated, then we will again combine it, and we will try to get the nth term of the single series, which is this question. And once we have calculated the nth term of this single series, we will be then able to calculate the sum of n terms of this given series. Is it okay? So I am trying to show you separately, roughly. First of all, the first series that we have is the one which is underlined. So according to the first series, the terms are 3, 5, 7 and so on. 3, 5, 7 and so on. So from here what we understand? The first term is 3, second term is 5 and third term is 7. Now the difference between these two is 2. That means the 3, 5 and 7 are in AP. Clear? Therefore, we can calculate the nth term of this first series by using AP formula. Okay? So, according to the AP formula, roughly I will show you here. Tn will be equal to, the first term of the series is 3. The formula for the nth term of AP is A plus n minus 1 into D. Right? Okay, so A plus n minus 1. N minus 1 into D. D is the difference between the two consecutive terms. So 5 minus 3 is equal to 2. Is it okay? Therefore, now simplify this. This is 3 plus 2n minus 2. Right? And this is then finally coming as 2n. 3 minus 2 is 1 plus 1. So this is the nth term of your first series. This is the nth term of your first series. Is this very clear? Likewise, now we will go for the second series. Second series is this one, is this one, is this one. Is it very clear? So, when you look at the second series, the first term is 5, second term is 7. Therefore, the difference between the two consecutive terms is again 2. So, we will find out the nth term formula for this another series, for the second series. Right. So, let us find out the nth term for the second series. Tn is equal to, here the first term of the second series is given as 5. So 5 plus n minus 1 into D. D is 2, right? Because it is 7 minus 5 is equal to 2. So operate it, simplify. 5 plus 2n minus 2, and this is equal to 2n plus 3, because 5 minus 2 is equal to 3. Now look here. I told you that this given series is a combination of double series, and therefore we have to find out the nth term of each series. So now we have calculated the nth term of the first series as 2n plus 1 and nth term of the second series as 2n plus 3. Right? Now, the two series are given in the form of product. The two series are given in the form of product. Therefore, when you calculate the nth term of this given series, you have to get the product of this and this. That will be your final nth term of the given series. So, we will get the actual nth term of this series by multiplying this and this. So, let me write 2n plus 1 into 2n plus 3. 2n plus 3. Is this very clear? Now let us simplify this. When you simplify this, everything will become clear. 2n into 2n, 4n square. 4n square. 2n into 3 is 6n. And then 1 into 2n is 2n. And 1 into 3 is 3. Is it okay? One more step here only. Because this question is little lengthy and I need more space. Now in this expression, in this part you can see 6n and 2n are like term. So they can be added together. Finally your question is, nth term is becoming 4n square plus 8n and then plus 3. So this become your nth term of this given series. This question is very tricky but very interesting. Now you might have understood that what will be the process of solving this question if you are given the terms in the form of product. In the form of product means it will be combination of two series. Therefore, we will find out the nth term for each series and then we will multiply. Why we will multiply? Why we are multiplying? Is because the terms are given in the form of product. That means the nth term also has to be multiplied. And therefore, finally we got the nth term of the whole series. Is this very clear? Now we will find the sum of this series. Now we are finding the sum of this series. So let us do that. So we will find out the sum of this series. Is it okay? So 4. Now n square is what? The minute you see n square, now you will start understanding. That means this talks about the sum of square of the first n natural number. And the formula for the sum of square of the first n natural number is n into n plus 1 into 2n plus 1. Right? Divided by 6. Alright? Now 8. 8n. 8 is 8 and n is the sum of n natural number. The formula for that one is n into n plus 1 divided by 2. Is this okay? Now, the last but not the least, the 3. This 3, when you calculated the nth term, you are getting this as 3. But when you are finding the sum, right, this 3 will be added for n number of times. Therefore, this 3, when you write this in the form of sum, please be mindful, we will write this as 3n. Because this 3 is going to be added for n number of times. Therefore, 3n. Clear? Now simplify. This is 2 3s are 6 and this is 2 2s are 4. This is 2 1s are 2. This is 2 2s are 4. 2 4s are 8. This is 2 4s are 8. Alright. Now what you can see here is in this 3 term there is something common and that is n. At least n is present in all the 3 terms. So let us take it out. This n will be out. So from this you are getting 2 remaining, right, over 3, right, and then n plus 1 into 2n plus 1. And from here you get 4 into n plus 1. And this will become 3. Is it okay? Let us operate it. This is n into 2 over 3. Then n plus 1 and then this is 2n plus 1, this open the bracket, plus 4n plus 4 and plus 3. So finally can we have the sum of this? This is equal to n into 2 over 3 n plus 1 into 2n plus 1, and this is 4n plus 7. Okay, after this step, then what we can do is, you can see here this is a fractional number because of this 3, right? So we will simplify. Maybe we will take this and then write 1 as the denominator. You will not be surprised whenever I write 1 as the denominator, because this is a fractional number and I want this also to be a fractional number. So we can operate now, and the LCM of this will be this is n as it is, and then the LCM of this whole thing will be n, all be 3. So this is 2. Now let us multiply this and this. N into n, 2n square plus n plus 2n into 1 plus 1, right? And then now here plus 1. Now this 1 divided by 3 will be 3, and 3 into this. So this will become plus 12n, and this will become 21. Clear? Next step. What? This is n over 3. This 3 I will write outside now, and inside now what will happen? Okay, this is 2 into 2n square. That means this will become, sorry, this was still here. We didn't use the bracket by mistake, so sorry. And now 2 into 2n square is 4n square. 4n square. Clear? Now this 2 and then n plus 2n, 3n. This 3n into 2 is 6n plus 6n. Right? And then this is n, 2 into 1, 2. This is 2 into 1, 2. This is 12n plus 21. 12n plus 21. Is it alright? Now once again we have light term, so we'll simplify. This is equal to n over 3, and 4n square is only one piece, single, so 4n square as it is. Now 6n n plus 12n is equal to 18n, and then 2 plus 21 is 23. 2 plus 21 is 23. Hope this is very clear. Any doubt? This is your final answer. Thank you. We'll see one more question of question number 3. Question number 3. Question number 2. In Roman number, in the first question, we had these terms in the form of product, and that's how I said that the given series is a combination of two series. Now here it appears to be in the form of a square. But please remember, this also is of the same type of question. Here also this is the combination of double series, right? How can we see this? Is this the series given are 1 square plus 3 square plus 5 square and so on, right? But actually this is 1 into 1, this is 3 into 3, this is 5 into 5 and so on. And therefore we can see this question also as the combination of two series. But here we are more fortunate because both the series are same. Both the series are same. So if we can find out the nth term for one series, then for the other series also we can get bonus. So let us right now calculate the nth term of the given series, right? Nth term of the given series. First term of the series will be 1 plus n minus 1 into d. The common difference is 3 minus 1 is equal to 2, right? And therefore this becomes 1 plus 2n minus 2, and so your nth term is 2n minus 1. Is this very clear? Now this is the nth term of your one series, that is 1, 3, 5, and then other series also same. That means for the other series also when you calculate you will get the same thing. Clear? So we can actually have the nth term of the series as the product of this and that previous one. This by itself. Multiply this by itself. So the actual nth term we can have is Tn is equal to 2n minus 1 into 2n minus 1. 2n minus 1 into 2n minus 1. 2n minus 1. Is this very clear? So we will multiply this and then we will take the result so that we can do it in minimum space. When you multiply it, you will get this as 4n square minus 4n n plus 1. So this is your nth term of this given series. Is it okay? So we will write the nth term of the series as Tn is equal to 4n square minus 4n plus 1. Is this very clear? Now we have to find the sum of this term of the series. Clear? I will delete this because I will need this space. Okay. So when we calculate the sum of this term of the series, I can write this as Sn of this all 4n square minus 4n plus, I told you the constant will be added for infinite for n number of times, therefore this will be 1n. 1n means it will be simply n. Is it okay? And now we can replace it by its formula. So Sn will be equal to 4 and n square, sum of the square of the first n natural number. That is n into n plus 1 into 2n plus 1 divided by 6. Now minus 4n. 4n. N is the sum of the natural number, which is n into n plus 1 divided by 2. And this is n as it is. Is it alright? Now let us simplify first of all. This is 2 2s are 4, this is 2 3s are 6. This is 2 1s are 2, this is 2 2s are 4. Right? So in the next step, we can have this as, okay, we will write the next step, but the same time we can see is n and n is common. So we will take out this n as the common factor. N is taken out as the common factor. What is remaining? From here it will be 2 into n plus 1, 2 into n plus 1 because this n is already out. 2 into n plus 1 into 2n plus 1, 2n plus 1 divided by 3. From here, this n is gone. That means we will be left with 2 into n plus 1 minus 2 into n plus 1. 2 into n plus 1. Clear? And this n is already gone out. So this will be your plus 1. Hope this is clear now. Okay. Now we can open the bracket and simplify with this. This part will remain as it is for the time being. This is equal to n into 2 into n plus 1 into 2n plus 1 divided by 3 as it is. Then we'll open this bracket, minus 2n minus 2, and then this is plus 1. Clear? Okay. Now this can be simplified because minus 2 and plus 1 are like term. So the next step we will have is n into 2 into n plus 1 into 2n plus 1 divided by 3, and this becomes minus 2n minus 3. Sorry, 2n minus 1. 2n minus 1. This is because minus 2 plus 1 is minus 1. Okay. Now let us simplify this. Let us simplify. We will simplify, okay, is equal to. When we simplify, before that, also I can take this minus sign as common out. No? One step, I will take more. N into 2 into n plus 1 into 2n plus 1 divided by 3, right? And then I will take out minus sign common, then this becomes 2n plus 1. No? If I take out the minus sign common, then I am getting a good result. That good result is that here and this, in these two terms, you can see 2n plus 1 is common. So we will take it out. Inside will become lighter. So n and then 2n plus 1 is out. Now inside the bracket, from here you are left with only with 2 into n plus 1. So let us multiply and then write this. So this is 2n plus 2. Okay. And then after you have taken out this common factor, okay, this is down is 3, and then this will become 1. Isn't it? Because you have taken out this as the common factor. Okay. Now we can simplify. Now this is a whole number and this is a fraction number. Again, I will make this also as a fraction number and we can simplify. So this is n into 2n plus 1, and then the LCM of these two will be 3. Numerator is 2n plus 2 as it is, and then this is minus 3. Clear? Finally, now this is n into 2n plus 1. Now inside here is this 2 and this is minus 3. So it will become minus 1. So 2n minus 1 and then divided by 3. This is your final result. Okay. There is one question in question number 2, that is Roman number 3, and that will be your assignment. Okay, this is the assignment for the day. Question number 2, Roman number 3, and question number 3. Okay, these two are assignment. Of course, the other questions also which I have taught you, you will practice, and then if you find difficulty, please contact me through WhatsApp group. Thank you. Have a nice day.